Twinkle, twinkle, little star, how I wonder what you are. Friends, don't worry, you are not in a nursery class. We are on Sudharma's physics classroom. So you will be wondering why I am here with a nursery rhyme, right? So today's topic is why stars are twinkling. From childhood, we were taught that stars twinkle, right? And what we see on the sky, on the beautiful sky, is the stars twinkling. And why don't the planets twinkle? We're going to understand the scientific principles behind these things. Okay? So, my question is why stars are twinkling and why planets do not twinkle? So, the answer for this question is it's because of some natural phenomenon, right? Or some phenomenon of light. And are these stars twinkling actually? What do you think? Definitely, it appears to be twinkling. It is not really twinkling. So, what is the phenomenon behind this? We were studying the chapter refraction of light, right? Refraction is it's a phenomenon of bending of light when it enters from one transparent medium to another transparent medium, right? So the light from the stars are very very far objects. It's a luminous source, right? Luminous object, and it produces its own light, and it gives a lot of light, and it's very very huge object, no doubt in that. So basically, for an observer on Earth, stars are at very large distance, right? So when the light from the star reaches the observer's eye, what happens is it has to travel through different layers of the atmosphere. So when it travels through the different layers of atmosphere will have different refractive index. It will have different optical densities because the temperature will be different, the constituent of the different layers, the gaseous molecules, the other molecules, everything varies from different layers to layers. So it will have varying optical densities or varying refractive index. So we know that when refractive index varies, the bending of light it varies, right? So when this light from the star, it is at a very large distance from the observer, we can consider it as point source of light. Very important term. It can be considered as point source of light. So when the light comes from that much distance and it travels through the different layers of the atmosphere which has different optical densities, the light undergoes refraction many times and we feel that it is flickering. So that is what we feel as the twinkling of stars. Okay. So the important points we have to mention is the stars are point source of light because it is at a very large distance from the observer. And once it travels through the different layers of atmosphere which has varying optical densities, the light undergoes refraction many times, right? And we feel that the light is flickering. Okay? That is called as twinkling of stars. And the star's position, what we see from the earth, it is not the real position of the star. It is called as apparent position of star. Because of, again, refraction of light, we have to mention it's because of atmospheric refraction of light. Atmospheric refraction. Because it's undergoing refraction through the different layers of the atmosphere. So we feel that we see the star, but it is not the actual position of the star. There will be a shift in the position of the star. That is called as apparent position of the star or apparent star position. And the reason behind this phenomenon is also atmospheric refraction. Okay. Now I had another question here, and why planets do not twinkle, right? Why planets are not twinkling? We can see Venus, right? Venus, it's very much visible from the Earth. But why we don't see that twinkling? Why it is not twinkling? Because the planets are nearby objects, right? For the person on the surface of Earth, the planets are nearby. Compared to the stars, the position of the star is very nearby. Even when we look at the moon, right? Moon, it gives light, but it's not producing light. It is reflecting the sunlight. But definitely, we can see the light on moon, but we don't see that the moon is twinkling, right? So the reason behind this is we have to see that the moon and the other planets compared to the stars, they are at a very small distance from the earth compared to the stars. Okay, definitely they are at large distance, but compared to the distance of the star, planets and moon, they are closer by objects. So we can consider that as an extended source of light. Instead of saying point source, stars are point source of light. Planets can be considered as extended source of light. So the twinkling effect gets nullified. It cancels each other. Okay, so since they are very close to the observer, we don't see that flickering of light when we see the light from the planets. See, planets definitely they are not producing its own light. It all reflects the sun's light. Okay, but still we can see light, but it will not flicker because it's near. It will we don't feel that flickering because they are closer to the observer. Okay, so that's about the twinkling of stars and why the planets are not twinkling. Now comes another very interesting fact called as advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. We are all very curious to see the sunrise and sunset, especially when we go to the beaches, right? So we will be observing the sunset and we'll be clicking the pictures by the time the sun goes to below the horizon. Okay, so actually, when we were trying to click the pictures, what we were actually seeing is the apparent position of the sun. Already, we have discussed about the apparent position of the star, right? So the sun is also another star, but the difference is it is very close to the earth. So when we see the sun, it is not the actual sun when we are seeing during the sunset and sunrise. So the interesting fact I'm going to tell is every day we are seeing the sun 2 minutes before the actual sunrise and 2 minutes after the sunset. So how is that possible? So here is the actual position of the sun. Because of the atmospheric refraction, okay, because of the atmospheric refraction, the person on the surface of the earth will be seeing the image of the sun. So this is the apparent position of the sun. This is the real sun. Okay. So suppose it is sunrise. So the sun is about to come above the horizon. Okay. So before that, we will be able to see the sun because of atmospheric refraction. If it is sunset, sun has already gone below the horizon. But still we are able to see the sun because of atmospheric refraction. And it is experimentally found that 2 minutes before the sunrise, actual sunrise, and 2 minutes after the actual sunset, we are able to see the sun and we are able to enjoy the sunlight. And we can say that the day is extended by 4 minutes every day. The daylight, we are able to enjoy the daylight 4 minutes extra. It's very interesting, right? So, hope you enjoyed this natural consequences of refraction of light. So, it took a long years to understand stars are not actually twinkling, right? Because we were taught from nursery school that the twinkle little star, right? Now, in grade 10, you are learning stars are not twinkling. It is the effect of refraction. We feel that it is flickering, and we call it as twinkling of stars. Hope you enjoyed it. If you have any doubt, please put it in the comment box. And in the next class, we will be discussing the text back question and answers of the chapter Refraction of Light. If you have not subscribed to the channel, please subscribe to the channel and click the bell icon for more updates on the classes. Thank you for watching. Bye.